How's it going, you guys? So today we're going to work on number of good pairs. And so the idea behind this is we want to get a good pair is one where the values are equivalent and uh, the first index is smaller than the second. So let's take a look at this example. So here, for example, index of 1 here is 0 and 3. So 0 and 3 would be a good pair. And also 0 and 4. And that's because the values are equal and the first index is smaller than the second. As well, let's see, 3 and 4 for these ones, and 2, 0, 1, 2, 3, and 5. Or 2 and 5 are the indexes for 3. So that's the idea here, is we want to find good pairs. Let's do this one here. So each pair is good. So 0, 1, 0, 2, 0, 3, 1, 2, 1, 3, and 2 and 3. And here, none of the values are equal, so we're going to get 0. We want to output the number of good pairs. So let's think about how we can do this. Okay. So we can create a hash map where the key is going to be a value and the index will be a list of locations in nums, right? So for 1, so let's do an example. So 1 would be, and with this example here, 1 would be 0, 3, and 4. And so we'd create this for the entire array. So we'd loop through this array, create our hash table, and then we can go through our hash table and find good pairs. So once we've created this hash table, we could see that, 0 and 3, 0 and 4, and 3 and 4. So there's 3 for this entry. Okay, so the plan is create hash table like this. And then for each key and table, we'll create, we'll call good pairs, set it to 0, and for each key in the table, good pairs, we'll increment it by, we'll create another function, get good pairs. It takes so we'll go like this. So we'll pull out the key and the value for the map that we've created, and we'll give this function the value, which like we showed is just this. It's going to be this list of indices or locations in nums. Okay. So that'll be num identical pairs, and then we have to create this get good pairs function. So it's going to take a list. It's going to be a mutable list. So one that we can add new values to it. So if we just give it list in Kotlin, this is read only, so we won't be able to add anything to it. So we need to use a mutable list to get right to access. It's going to return an int. Okay, so what is this going to do? So we're going to count. So the key here is we know we are getting a list where all the values are equivalent, where this is already satisfied, right? Because the key here is a value within nums. And so its value is all the indices where that key is located in nums. So we just need to check, within this mutable list, we want to find all pairs where one index is smaller than the other. So how can we do that? We can just loop through twice. For I in L dot, okay, mutable list, size, colon. How do we get that? Size, I guess it's just dot size. Just want to make sure. Size, huh. Okay, that's the wrong thing. Go to the next entry. Size, okay. So that'll give us the size in for I in 0 until L dot size. And, oops, we don't need to do that for our pseudocode. And let's just copy that. We'll call this J. What are we going to do for each one? If I is less than J, let's make this good pairs. Sum value. We're gonna add 1. We're gonna increment good pairs. And then we'll return good pairs. And so that's gonna count. So like, let's say we have 0, 3, 4, right? So these are the locations of 1. So it's 0, 0, 3, and 4. So it's going to loop over this list, and when I is less than 3, it's going to add 1. So 0, 3 plus 1, 0, 4 plus 1, 3, 4 plus 1. So it should return 3. Okay. All right, let's try it out. Oh, and let's think about the runtime and space complexity. Okay, so runtime, so time complexity. Let's see, there's 2 loops. The first loop is going to, so to create the hash table, you have to loop over every single element. So that's at least n, the size of the nums array. What else? And we do this second loop, although it's not a nested loop, so it's still going to be O of n. O of 2n is just O of n, as n gets very large. And then there's this loop here. So it is a nested loop. So a nested loop is O of n squared. Right? Like say we get a really long list. Oh. Yeah, so if we get, like if the input here, L, is large, the runtime is going to be proportional to the size squared. O of n squared. Okay. Yeah, I think that's O of n squared. Let's see, space complexity. Let's think about this. So we're going to need space for the hash table and a few variables. The size of the hash table is going to be proportionate to the size of the nums array. So as nums gets larger, the hash table will get larger. Yeah. If you guys have any other thoughts on space or time complexity for this problem, go ahead and let me know in the comments. All right, let's give this a shot. Okay. So we're going to create a hash table. We're going to let's call it indices. It's going to be a hash map of int and mutable list of int. Okay, so now let's populate our hash map. Okay, let's see, for index in nums dot indices, which will go from 0 until nums dot size minus 1. Although it is kind of confusing because we've named our thing differently. So let's do 0 until nums dot size, just so we don't get confused. Okay. So if indices does not contain our an index, we want to add it. And if it does contain an index, we want to, so if, okay. So let's call 1, 2, 3. These are going to be values. And then its index will be an index. Okay, value and index. This is confusing. Okay, so let's call this something else. Index map. That's a little bit better. Okay. So if index map of nums index. So if our index map doesn't contain a value yet, this should return null. And if that's null, we want to do index map nums index mutable list of, we'll give it index. And if it's already, otherwise if we already have, it already contains a value here, we want to add our new index to that list. So we're going to go index map nums index, which should give us a list. We're going to add index. And so for Kotlin, when we access a map like this, this could be null. So this map could be null. Even though we've checked here, yeah, I'm not sure why this isn't working here, but normally, like when you check that this, so this if statement assures us that this value exists in index map. So we shouldn't need to do this, but for whatever reason, we need to assure leak code that this is not null. And we do that by putting 2 exclamation points before we access it with the add function. Okay, let's keep going. And so now we need to get good pairs. Set this equal to 0. And how are we going to do that? We're going to do a for loop. We're going to loop over the keys and values of index map. And what are we going to do? We're going to set good pairs. We're going to increment good pairs by the number of good pairs within, like, let's say for 1, right? Okay. To value. And then when we found good pairs, we want to return good pairs. Okay, so now we need to create our good pairs function. Let's copy this a little quicker. Okay, let's see here. So we've got this immutable list. Okay, we need to do this. This. Okay, this should work. All right, let's give it a shot. Okay, what error do we have here? Okay, so we have to give it a type. It's going to be an int. Okay, there we go, you guys. So so I'm thinking this is O of n squared, right? Because if we get a really big nums array, we have this nested for loop here, and it's going to have to go over it n squared times. So let's take a look and just see if there's. Oh, it looks like they have O of n solution. So it looks like they're able to get O of n with the map. So we did the O of n squared solution. You can go ahead and check out the discussion to try and find an O of n solution. All right, you guys, that has been, what's this called again? Number of good pairs. All right, see ya.